In example 2, that we're going to learn how to add and subtract complex numbers. The first thing they wanted you to do is know what a complex number is and break it down into its parts. So the sums of real numbers and real number multiples of I belong to an extended system of numbers known as a complex numbers, and we looked at that complex number system earlier. The complex number is a number that can be written in standard form. Now, standard form is an important number, and I highlight that, or an important language. It's A plus BI. A plus BI is the way that you should write each of these. Now, A and B are both real numbers. So A is a real number, and B is a real number, and I is your imaginary part. So we got this real number A, and it's called the real part, and we also have the imaginary part where B is involved. So A plus BI, where A is the real part, BI is the real part, but A and B are real numbers. Now I start getting into some if situations. What if A was not equal to 0, but B was equal to 0? If our real number B was equal to 0, then the complex number would be A plus 0I, and there aren't any imaginary parts, or it'd just be a simple real number. So therefore, every real number has to be a member of the complex number system, so we say it's a subset. So real numbers are a subset of the complex numbers. Now if B is not equal to 0, so they're saying in this standard form, if B isn't equal to 0, then you're always going to have a complex part to it, or an imaginary part. So if that's the case, you have that complex number is known as an imaginary number because it has an imaginary part. If A is equal to 0 and we don't have any real part whatsoever, so I block that out and I just have BI, that is known as a pure imaginary number because we don't have any real part in front of it. So we can break this standard form down into, we could just have, look at my cursor, just a real part. We could have a real and imaginary part, or complex part, so or real and imaginary, and that's called an imaginary number, or we could have just the imaginary part, which is called a pure imaginary number. So we can break it down into parts, and that's what that is emphasizing. Complex numbers can be added and subtracted by performing the chosen operation on the real and the imaginary parts separately. Now the way I translate this is, what we're going to look at is looking for the things that are like terms. The real parts are like, and the imaginary parts are like, so we're going to combine those and see how many real parts we have and how many imaginary parts that we have. So if I look at this example, what we want to do is find the real parts, the real part in this and the real part in that. That's a 5 plus a negative 2, which is a 3. The imaginary parts are negative 3i and a positive 4i. Well, that would give us just one positive I left. So that's simply how we add complex numbers. There's really no big trick to it. When we subtract, we have the same difficulty that we have with all parentheses, difficulty or obligation. We must distribute the negative through the parentheses because we want to subtract both the 14 and subtract the negative 6i. So I would suggest distributing your negative, so minus 14 and then plus 6i. And then when you add these, you're going to collect your like terms. 10 and a negative 14. Our real parts, we have negative 4, and then we want to collect our imaginary parts. Negative 2i and plus 6i is a positive 4i. Now these are written in standard form. It is in the A plus BI form. A is a negative 4, B is a 4, and that's your standard form of a complex number. So adding and subtracting, keep in mind you're just going to collect the like terms.